Thank you very much. So I will present you today with some progresses on the development and testing of new systems for restoration based on electrospun, non-woven mats, and greener solvents. So I won't dwell too much on this because my colleagues before have explained very well which are the issues related to cleaning and the type of materials that you be facing when you're cleaning. So we go from yellowed varnishes to corrosion products or vandalic acts, and the systems on which conservatory restorers frequently rely may have some disadvantages related to residues or unwanted interactions with the layers to be preserved. Therefore, research is focusing on developing new green systems and which are not invasive also towards the work of art. So we have focused on the selection of greener solvents, so we thought of ethyl lactate, gamma valerolactone, and dimethyl carbonate, which are deemed to be non-toxic and environmentally safer. And coming to the safety of the work of art, we selected as retentive system non-woven mats. So the technology that we use is the electrospinning. It's a very versatile technique that is employed in a broad range of fields, going from tissue engineering and electronics. And you are able to produce non-woven textiles with micro to nano porosities, which have sorbent properties, meaning that they have been already used for wastewater filtration or micro extraction. So we produce different types of materials. We go from plain, simple non-wovens made of polyamide 6,6 and pullulan, which is a bio-based polysaccharide, or more complex systems where we have not only the fibers, but also nanoparticles of melanin, which are photothermal agent. And you can tune the application. So the plain systems are used for the removal of triterpene varnish from paintings, while the more complex systems are used to remove highly insoluble reticulated acrid spray paints from marble. And in the meanwhile, within the project, we are also cooperating with an Italian company for the upscaling of the production of these materials. So I'll start with the removal of varnishes, which is the research that led us to patent this application. So first, we started with polyamide 6,6, which is not a green polymer, but it's very easy to tune its production. So we wanted to investigate the morphology effect on the cleaning properties of these materials. So we produced three mats with an increased fiber diameter and pore size, and we studied not only the morphology, but also the retention of our solvent. And we tested them on a mock-up. So how you clean and how we assess, you have a precise ratio of solvents volume to mass of the mat. You apply it on the surface that you want to treat. You wait from 2 to 5 minutes, and then you have a peel-off, like waxing your legs, but without pain, of the varnish. So then, of course, we employed a multi-analytical protocol to study not only the efficacy, but also the mechanism. So we employed different imaging and spectroscopic techniques. We started testing our new materials on a mock-up, and we observed that when we increase the pore size and the fiber diameter, we have a decrease in the cleaning efficacy, so we have more residues. So with SEM on sections of the mats after application, we observed that when we have small pores, we have a distribution of the varnish within the entire section of our mat. This is the side in contact with the painting. While when we have big pore sizes, we have still the varnish within the section, but confined in the lower part. So this and other studies led us to identify the capillary rise as the main mechanism leading to the cleaning. So the smaller the pores, the higher is the capillary rise. So we were left after this with two main perspectives. So finding a greener alternative, because as I said, polyamide 6,6 is not green, and also the solvent that I use to produce the matte is not green, and it's really toxic. And also testing these materials on an historical case. So the alternative that we found is pullulan. So as I was saying, is a bio-based polysaccharide, and we produced it with the same fiber diameter and similar pore size to the polyamide 6,6 that we observed that was the best one in terms of cleaning. And as you can see also, the solvent retention is unchanged, meaning that the chemical properties of the fibers are not affecting the evaporation and retention of the solvent. Sorry, this is not. And then coming to the testing on a historical case, the Courtauld Gallery, the Institute of Courtauld Gallery, which is a partner in the GoGreen project, provided us with a painting from the 19th, 20th century with the damar varnish yellowed on top. And we tested both the polyamide with the small and intermediate pores and the pullulan with two different solvents, so gamma valerolactone and dimethyl carbonate. And we tested different time of application, and here you have a grid of the initial test that we performed. As you can see, we had a good success, so we had more than half of the tests with a good cleaning performances, but what really impacted our cleaning efficacy was not the kind of tissue, but actually the solvent that we selected. So this varnish was way older than the one on our mock-up, so more polar, and that's why gamma valerolactone led to better results than dimethyl carbonate. Then, second kind of material, so the more complex one, as I was saying, is made of pullulan and melanin nanoparticles that we extract from cuttlefish, from squid ink. So it's green, but not actually vegan, but they are photothermal agents, meaning that you can increase locally the temperature. So, of course, we started with the study of the morphology, and as you can see, this is plain pullulan, SEM and TEM pictures, and you can see that the nanoparticles are inside the fibers. So this means, and we also perform some studies, that the particles remain confined in the tissue. So when you wet the mat and you apply it on your surface, you don't have release of nanoparticles, so you don't have risk associated with it. And then we studied the photothermal properties. So once you irradiate with the red light your mat, you have an increase of temperature, and you have a linear correlation with the irradiance of the lead and the maximum temperature reached. And as you can see, generally the front, so the side which is directly irradiated, has a higher temperature compared from the back. But this is a dry mat. When you add the solvent, so in this case gamma valerolactone, the maximum temperatures of the back and the front are almost the same. So this means that when you are applying your mat on a tissue and you are irradiating, you cannot monitor directly the temperature in contact with the object, but you can only monitor the temperature on the surface. So what you know is that the temperature in contact with the object is at least the same of the one that you are monitoring on top. We tested different conditions, so with and without irradiation, and with and without solvent, and as you can see, not only irradiation is necessary to remove the reticulated alkyd layer, but you need also the solvent, meaning that to increase enough the free volume and the chain mobility, you need both actions. So only solvent doesn't work, plain or with melanin nanoparticles. Only temperature increase doesn't work, but when you add the two effect, you have a good cleaning efficacy. And we have also performed hyperspectral imaging on the area cleaned, and actually what our eye cannot see is that still we have some residues on the marble surface. So it's still, we are still investigating how to increase the cleaning efficacy, but as of now we are quite satisfied. So to wrap up, we are able to have a peel-off effect during the removal of natural varnishes from paintings. We are able to tune our materials in order to meet specific requirements, for example, for the removal of highly insoluble spray paints, and we managed to achieve a sustainable production of our materials. As perspectives, we'll still have to investigate the removal of synthetic varnishes from paintings, the selective removal of spray paints when you have an underlying layer of spray paint, so this is also done in collaboration with the national project of national interest, Superstar. We are working with our colleagues in Switzerland for the removal of corrosion products from metal objects. And of course, we are also investigating new analytical protocols to have more reliable results on the assessment of residues and efficacy. So, thank you very much for your attention.
Thank you very much, Francesca. Nice new developments, the combination of new types of tissues, solvents, but also the local application of heat. That's an interesting innovation. One question from the audience. Thomas.
Thank you, Francesca, for your presentation. I just have an interesting question about the temperature and about the capillary action. It's actually the same effect that you also have in hydrogels, depending on the pore size, and also but that's also related to the temperature, as the pore size may change as the temperature rises. And I was wondering, since you're using also heat transfer, and which adds efficacy to the cleaning action, but at the same time you will be increasing the weave size unless your tissue is dimensionally stable in temperature changes. So I was wondering if it's how do you deal with that? Is it dimensionally stable within this temperature increase or not? And then what do you think about it? So that as regards capillary action. Thank you.
Thank you for your question. So the mat, it's stable, so the fibers are stable during irradiation, and we have checked also after irradiation the mat properties, and they are unchanged, and also the ability of reheating. We can reheat up to 5 cycles, and we don't have any morphological variation of the mat. And actually, sadly, with the reticulated spray paints, we don't have a capillary rise because we are not solubilizing them. We are just swelling them and softening them. So we need a brush or a swab to remove them because reticulated polymers cannot be solubilized. So you cannot have a flow of a liquid within the capillaries, but we are working for the removal of waxes, and hopefully we can match both capillary rise and temperature and have a good result. So thank you for your question.
Okay, thank you
Thank you.
once again.